Welcome, class, to the Intro to Java Programming. In this lesson, we will review polymorphism, one of the major building blocks to object-oriented programming. Method overriding will be the focus along with some visual and code examples. Object-oriented programming is about creating objects that contain both data and methods. The four building blocks for object-oriented programming are encapsulation, inheritance, abstraction, and polymorphism. In this lesson, we'll focus on polymorphism. Polymorphism means existing in many forms. With the use of contracts, overloading, and overwriting, we can enforce simplicity, which helps make the code more extendable and easier to maintain. It lets programmers use the same word to mean different things in different contexts. Yes, this definition is a little vague until you better understand the true meaning. Polymorphism means existing in many forms. Specifically, classes and methods can exist in many forms. Let's review the three types of polymorphism. Dynamic polymorphism, often referred to as method overriding or runtime polymorphism. Static polymorphism, often referred to as method overloading or compile time polymorphism. And finally, object reference polymorphism. This lesson will focus on dynamic polymorphism. Dynamic polymorphism is achieved with method overriding. Overriding is when a child class has its own implementation of a method provided by the parent class. This can be done with inheritance of a class, an abstract class, and an interface. Each class can have a public or abstract method, for example, getMonsterName. In the class, let's say it returns a value defaultMonster. The interface is an abstract method with no code block. The abstract class could be either. Let's use another abstract method. Let's call this parent class a monster. There can be another class that extends or implements the class. Call this child class a goblin. With dynamic polymorphism, the child class can also have a method called getMonsterName. Let's say the child returns a string value, goblin. The child class can override the parent getMonsterName method. Let's imagine there's a game control class that instantiates the goblin child class as a goblin data type. If the game control object calls the child object and requests the getMonsterName method, the value goblin is returned from the child class. The child class overrides the parent class. The child overrides the parent for abstract methods in the abstract class and interface because there is no code in the parent. If the game control object instantiates the goblin child class as a parent or monster data type and requests the getMonsterName method, the value goblin is returned from the child class. Again, the child class overrides the parent class. This is true for the abstract methods in an interface and abstract class. When overriding a parent method, place the annotation @override above the method. This annotation is not required but very helpful to other developers as a clue the method is overriding a method from the parent class. The child is required to override all abstract methods in the parent to become a concrete class. With inheritance of a class, the child is allowed to override public parent methods. However, it's not required to override any method. The child can utilize parent methods and has the option to override those methods where a different functionality is needed. Let's look at overriding non-abstract methods. If there's a goblin and skeleton class that extend the monster parent class, the goblin class could override the getMonsterName method, and the skeleton class does not override the method. If the game control object calls the goblin child object, the value goblin is returned. If the game control object calls the skeleton child object, the value defaultMonster is returned. Overriding a method is optional for non-abstract methods. Polymorphism means existing in many forms. As you can see with these examples, one method call has many forms. Let's look at the code for overriding. Open the OOP project in IntelliJ, close any open class tabs. Let's create a new test package called Polymorphism. Let's create a new class called Dynamic Runtime Polymorphism Test. Let's move this over a little bit so we can see everything. This first test will prove the child method can override a parent method. A new goblin polymorphism inheritance object is instantiated as the variable name goblin. Please note that the data type is a Goblin polymorphism inheritance class. This assert will prove the child method can override the parents. This assert will prove the child can return the parent's overridden value. And this assert will prove a child can return a parent-only method. This test is similar except there is no child method to override the parent method. Notice that this assert proves no child override method was found, but the parent method value is returned. These two asserts are the same as the previous test. This test will prove a child method can override a parent method. A new Goblin polymorphism inheritance object is instantiated as the variable name parent. Please note the data type is a monster polymorphism inheritance class. This assert will prove, as the parent, the child method override is returned. This assert will prove, as the parent, a child-only method is not accessible. And this assert will prove a parent-only method is available. This test is similar except there is no child method to override the parent method. Notice that this assert proves no child override method was found, but the parent method value is returned. This assert will prove, as the parent, a child-only method is not accessible. And this assert will prove a parent-only method is available. The next four tests will prove the same features work for an abstract class as well. This test will prove, as a child data type, if there is a child method overriding the parent's method, the child value will be returned. This test will prove, as a child data type, if there is no child override method, the value from the parent method is returned. This test will prove, as a parent data type, if there is a child method overriding the parent's method, the child value will be returned. And this test will prove, as a parent data type, if there is no child override method, the value from the parent method is returned. The final two tests will prove method overriding with an abstract method from an interface. This test will prove, as a child data type, the abstract method from the parent is overridden by the child and the child value will be returned. And this test will prove, as a parent data type, the abstract method from the parent is overridden by the child and the child value will be returned. Let's create a new Java package called Polymorphism. Let's create a new class called Monster Polymorphism Inheritance. There are two public methods. One method will be overridden for several test examples, and the other method will not be overridden for the test examples. Create a new class called Goblin Polymorphism Inheritance. This is a child class. Notice that the Goblin Polymorphism Inheritance is extending Monster Polymorphism Inheritance. There are two public methods. One method will override the parent method, and the other method will return a value of the parent method using the keyword super. Create a new class called Skeleton Polymorphism Inheritance. This is another child class. Notice that Skeleton Polymorphism Inheritance is extending Monster Polymorphism Inheritance. There is only one public method, and it will return a value of the parent method using the keyword super. There are three other classes needed for the abstract code examples. Let's create a new class called Monster Polymorphism Abstract. There are two public methods. One method will be overridden and the other is a parent-only method. Create a new class called Goblin Polymorphism Abstract. Notice that Goblin Polymorphism Abstract is extending Monster Polymorphism Abstract. There are two public methods. One method will be overriding the parent, and the other will return a value from the parent-only method. Create a new class called Skeleton Polymorphism Abstract. Notice that Skeleton Polymorphism Abstract is extending Monster Polymorphism Abstract. There is only one public method that returns a value from a parent-only method. There are two classes needed for the abstract method and interface code examples. Let's create a new class called Monster Polymorphism Interface. Be sure it says public interface and not public class. There is one abstract method. Create a new class called Goblin Polymorphism Interface. There is one public method. This method implements the abstract method from the parent and uses the keyword @override. Let's go back to the test class. There are several compiler errors. All of them will prove accessibility issues with the parent and the child class as noted before. These two lines prove that the parent cannot access public child methods. Let's comment these lines out. Scrolling down, there are two more. These two lines prove that the parent cannot access public child methods. Let's comment these lines out. Let's run all 10 tests for this class. And they all pass. Here's a summary of all the code we wrote for this lesson. You should now have an understanding of dynamic runtime polymorphism with method overriding. Visual and code examples were provided for parent-child relationships and how a method from a child can override a method from a parent. Abstract methods must be implemented and overridden by the child or concrete class. Polymorphism means existing in many forms, and method overriding is one way it can be accomplished. In the next lesson, we'll discuss static compile-time polymorphism with method overloading. Remember, future senior developers, make it work, prove it works, then make it better. Ready? Break!